Hello friends, here is yet another way of deducing the expression for pressure for ideal gas. So for this we have to use a uh, bit of extensive mathematics to do it. So for example, we have to consider the wall of the cylinder on which you have a elementary surface area which is called ds, and we have to consider a point P from where the molecules are incident on this particular surface, and the length of this particular point P to the elementary surface is r, and let the normal to this surface area be L M N. So obviously we will have this angle as theta and this whole angle as d omega. So if we consider P the force per area, then we have Lx plus My plus Mz into P into ds multiplied by half. This half is entirely due to the reactive force when the molecule strikes with a velocity with a force p and rebounds back with a velocity v, and the force is again p. So p, the difference of force will be p plus p minus p, which is equal to 2p. So in order to half that force, we have used this half as a factor on this particular stuff. So this part will be replaced by r cos theta. So what do we have? Half into r cos theta into p ds. Now you can replace this whole thing in terms of the solid angle. Then we have half r cube d omega. Now integrating over this d omega, half r cube d omega, we obtain 3 by 2 dv. So here what we have is that half of the kinetic energy mc square is equals to 3 by 2 pv. Since we have not considered the intermolecular interaction between them, so what we will do is we will normally introduce a term, for example phi, which is responsible for the intermolecular interaction. Now this phi can be replaced as half mc square. Obviously here you have to put one summation. Half mc square is equals to 3 by 2 PV minus, and this P can be replaced as half into the potential energy of the system, which is small x capital X plus small y capital Y plus small z capital Z. This is as obtained, and this can be referred to as the complete virial equation for a non-ideal gas. In case of a non-ideal gas, this part is obviously equal to 0. Since we are considering it to be a non-ideal gas, so what we have, 1 by 2 mc square is equals to 3 by 2 pressure volume minus 1 by 2 summation of small x capital X, small y capital Y, and small z capital Z. So this is what is as depicted in this virial theorem, complete virial theorem for non-ideal gas. Thank you.